So, hi students. Today we are discussing uh, a new topic called normal distribution. So this comes in the first module, that is the syllabus. In your syllabus, the special distributions are that. In that one of the continuous random variable distribution is normal distribution or Gaussian distribution. Things we are going to discuss today. So our objective is to revise what we have studied so far, and the probability density function for normal distribution, and also we have to discuss about cumulative distribution function, then what is the mean and variance of normal distribution, and also we will discuss some problems based on normal distribution. So coming to revision, we have so far seen that the mean of a random variable is given by mu x, or it is called expectation of x, will be summation over kx k px of xk. So we have denoted it as fx of xk. So it can be denoted either probability of xk or fx of xk. When x is discrete, it will be summation. When x is continuous, it will be minus infinity to infinity x fx of x dx. And the variance of a random variable is sigma x square, is represented where of x expectation of x minus expectation of x whole square, or the other notation is expectation of x square minus expectation of x whole square. So for discrete, it will be x minus mu x p of x summation over k, and for continuous it will be integral minus infinity to infinity x minus mu x whole square fx of x dx. So these are the things we have studied, and we have discussed the different distributions such as Bernoulli distribution, exponential distribution, uniform distribution, etc. Now today we discuss about the normal distribution or Gaussian distribution. So the probability density function, first we are going to discuss about that. So the probability distribution, the PDF density function is given by, for normal distribution, as fx of x is equal to 1 by root 2 pi sigma, which is the amplitude, and it varies exponentially minus x minus mu whole square divided by 2 sigma square. Now the terms, sigma is standard deviation, sigma square is variance, and mu is mean. So in this problem, mean and variance will be given, and we have to find the distribution. Now normally it is represented as n of mu comma sigma square. So normal distribution of with the mean will be given and variance will be given. So we know that most of the naturally occurring phenomena which represents most of the things in mean, nearer to mean, and it decreases as you move away from the mean. Or if you see all the natural phenomena, so all those things can be approximated to normal distribution, and you can predict the values naturally occurring random phenomena. Now if the mean is 0 and the variance is 1, it is n of 0 comma 1, and it is called a standard normal distribution. So we'll discuss about this one in earlier chapters also. So here we will just see how to find the cumulative distribution function and thereby solve the problems. So we know that cumulative distribution function fx of x is minus infinity to x fx of x dx. Capital fx of x is minus infinity to x small fx of x dx. So if you substitute for fx of x, we know that fx of x for Gaussian is 1 by root 2 pi sigma e raised to minus x minus mu whole square divided by 2 sigma square. So in order to avoid these confusions between x here and here, I am using different notation for x, that is alpha. So alpha minus mu whole square divided by 2 sigma square. Instead of dx, I am using d alpha. Now that will be 1 by root 2 pi sigma. These all things are constants here, only the variable is alpha and d alpha. So which I can take outside is 1 by root 2 pi sigma. So this is integral. Now in order to simplify this one, we have to see about the distribution, how it comes. Now if you plot the graph, that is, it is having 1 by root 2 pi sigma as the magnitude, and it distributes with the sigma as variance, and the center of that one will be at the at mu. Center is at mu and it distributed across. Now if you want to bring this graph to the center, to mean as 0 and make it narrower, we have to do two things. The x should be subtracted with the mu, so that it should be shifted towards 0, and it should be divided by sigma, so that the mean becomes 0, which becomes a standard normal distribution. Now from this to this conversion, the operation required is x should be shifted and scaled, x minus mu divided by sigma. Now I am calling that as a new variable z. Now if I shift x, I have to do the same operation for alpha also, because instead of x I have used alpha there. So alpha minus mu, same operation, alpha minus mu divided by sigma, and I am calling that as a new term beta. Now if you find d beta, that will be 1 by sigma, because you have to find the derivative here, d alpha, this will be constant, so 0, so here divided by sigma. So d beta is equal to 1 by sigma d alpha, and d alpha will be sigma times d beta. So if you substitute those things in the expression, so fx of x will be 1 by root 2 pi sigma minus infinity to x was there, so I am scaling x to x minus mu by sigma e raised to alpha minus mu whole square divided by 2 sigma square. So I am taking all those square terms together, so alpha minus mu whole square by sigma whole square by 2 d alpha. Now alpha minus mu by sigma was beta, and d alpha was sigma d beta. So if I substitute those things here, so it will be 1 by root 2 pi sigma minus infinity to x minus mu by sigma is z e raised to minus beta square by 2 sigma d beta. Sigma will cancel, and our fx of x will be a function of purely z, phi of z, because I have to integrate from minus infinity to z, 1 by root 2 pi minus infinity to z e raised to minus beta square by 2 d beta. Now fx of x is phi of x minus mu by sigma, phi of minus z is equal to 1 minus phi of z. So we'll see why this expression is very important. So whenever we want to calculate fx of x, we have to convert x to z by finding x minus mu by sigma. Remember this one, this is very important. Fx of x is phi of z, where z is calculated from x by x minus mu by sigma. Take the value of x, subtract the mean, divide by standard deviation. Now if it is negative, I have to use another expression. Now coming to the mean, we know that mean is mu and variance is sigma square. It will be already given in the question, so no need of especially finding those values. Now, so how to find that one if the expression is given? So fx of z is now phi of z, fx of x is now phi of z, so it will be minus infinity to e raised to, I have used beta square, here it is eta. Now so phi of z is minus infinity, so from the negative side to this point we have to integrate. So integration is nothing but the area. So what happens here when I want a negative? So if I want area up to negative point, I cannot, this values will be given in a table. For z, what is the value of this integral? But that table consists only positive values, so from the table I cannot find the value for negative z. So but we can derive from the graph itself. If you see here, it is from minus infinity to z, means this part of the area. So that is actually the since this is symmetrical, this part is and this part are similar, the area under this curve is similar to area under this curve. Now this is more than z, less than z means it will be phi of z. So this area we know as phi of z, where z is positive. So this area will be total area minus phi of z, so that will be 1 minus phi of z. So we'll understand this one while doing the problem. So See this problem. A production line manufactures 1000 ohm resistor that have 10% tolerance. Let X denote the resistance of a resistor. Assuming that X is a normal random variable, means it can take any value with the mean 1000 and variance 2500. Find the probability that a resistor picked at random will be rejected. So what and all things are given here. Resistor is given 1000 ohm, that is X, and mu equal to 1000, mean is given, sigma square is given. As I said, in normal distribution problems, mu and sigma square will be given. What we want is mu and sigma. So sigma will be root of sigma square, that will be 50. Now it is mentioned that the tolerance of the resistance is 10%. Now 10% means 10 by 100 of 1000, that will be 100 ohm. Now what do you mean by tolerance? The resistor can take a value less plus or minus 100. So it will be 1000 plus or minus 100, means it can take the value between 900 to 1100 ohms. If any value less than 900, means it will be rejected. Any value greater than 1100, it will be rejected. So R is rejected if X less than 900 or X is greater than 1000. So here it is a OR operation, means union. You have to add the probabilities. So probability of rejection is probability of X less than 900 plus probability of X greater than 1100. So what we have to find is fx of 900 plus 1 minus fx of 1100, because greater than 1100 is 1 minus that value. So how to find fx of 900? I said fx of x cannot be calculated directly. Instead we have to convert x to z, then we have to find the value from phi of z. Now if you see fx of 900, that will be, so 900 is x, so x minus mu by sigma, phi of x minus mu by sigma. So x is 900, mu is 1000, sigma is 50, so you will get 9 minus 100, that is minus 100 by 50 will be minus 2. So phi of minus 2. I said phi of minus 2 cannot be calculated directly, so I have to use 1 minus phi of 2 according to the equation. So similarly fx of 1100 will be 1100 minus mu by sigma, so that will be 100 by 50, that will be phi of 2. Now what is phi of minus 2 and what is phi of 2? Phi of minus 2 is obviously 1 minus phi of 2, and phi of 2 will be, so how to calculate this one? So we have a table which I have shared it to you to take a print out, the table of normal distribution. So phi of 2 is when z is equal to 2. If you see here, z is 2 is here, so 2.00, actually 2 means 2.000 up to 2 decimal points. So 0.00 comes here and the value will be 0.9772. So once this value is obtained, so what we have to do, you have to apply this one in the problem. So probability of distribution will be fx of 900, that is 1 minus phi of 2 plus 1 minus fx of 1100, that is 1 minus phi of 2. 2 times 1 minus phi of 2 will be 0.045. So you can try this one in your, so students, please note down this theory and problem in your notebook, and also there will be a quiz given in the next section, which will be a theoretical quiz, simple quiz. Please attempt that also, and this is about the normal distribution. In the next class we will see about Poisson and Laplace distribution. Thank you.